Hello everyone, this is Ahmed Rahmi from Department of Construction Engineering and Management in KFUPM University. Today I'm going to present a review article about the evolution and the future of manufacturing. This article is extracted from Journal of Manufacturing Systems, which was published and available online on 16th of April 2016. As you can see in front of you, the abstract and the keywords for this article. This paper presents a holistic view of manufacturing by analyzing a broad range of publications covering myriad sub-areas and topics. This literature is organized into 8 main disciplines. The first discipline is technical and engineering aspects of production systems. The second is the planning aspect. Third, taxonomies of manufacturing systems. Fourth, designs for manufacturing. Fifth, remanufacturing. Then, sustainable manufacturing. New manufacturing paradigms. Lastly, but not the least, advanced manufacturing concepts. Let's start with the technical and engineering aspects. From manufacturing processes, we have variety of processes that can be applied to the materials, starting from casting, cutting, forming, and fabrications. Each technology will be applied to the material and to the metal based on its requirement and its desires and its serving functions. The more comprehensive classification is provided, in which processes are classified into 6 subcategories: casting, machining and finishing, joining, sheet metal, polymers processing, and deformation processes. We can see here that we have joining technology, where several parts are joined to form a new part, such as welding and assembly. We have dividing technology, like sewing and disassembly. We have subtractive technology and material removing, such as machining operation and grinding. We have transformative technology, in which a single work of a piece is transformed to another one without a change in the mass. We are using here the heat treatments principles. Then we have the additive technology, which we are, like for example, we have rapid prototyping, die casting, and injection molding. From the industrial control systems, in the industrial control systems, it includes and comprises of supervisory control and data acquisition (SCADA) system, distributed control system (DCS), small single control devices such as programmable logic controls (PLCs), sensors, and actuators. Although the ICS have a little similarities to the modern IT systems, ICS need different performance and reliability requirements than the typical IT systems. So many researchers applied in the information security related to the ICS have become also a focal point. We are going here to talk about one terminology, which is the resilience. The resiliency is introduced as one of the most critical objectives of today's complex industrial control system. The resilience by its nature, it's how much can the person resist the overcome and the burden circumstances and to survive from that circumstances. So resilience is how to maintain acceptable levels of the operation in face of the undesirable incidents like security, stability, efficiency, and the human interactions. For the industrial robotics, we are going to present some features of the robots in manufacturing applications. The features of the robots are ability to quickly, repeatedly, and accurately perform the operations. Production flexibility, the ability to produce large product variety and to avoid the major 3Ds, which are dirty, dangerous, and difficult jobs in many applications, such as the welding, material handling, painting, and palletizing. For the material handling system, we know that the cost of the material handling consists of 15% to 70% of the total manufacturing cost of the product. And here it became a substantial subject to tackle and to focus on. How are we going to handle the materials, whether the raw materials or the finished goods? So we have various technologies and we have various methods actually to handle these materials, such as industrial trucks, floor conveyors, overhead conveyors, automatic guided vehicles, cranes, and manuals. For the storage and the warehouse management systems, WMS, also we have actually automated storage and retrieval systems, we called ASRS. This was initiated in the late of 1970s and its development continued over the years. ASRS is a typical application of the automation technology in the modern logistics. Currently, there are joint applications for the RFID, the radio frequency identification technology, and the lean manufacturing, which can result in saving the total warehouse operation time by 87%. The second aspect was the planning aspect. So, for the operating rules and the process planning aspects of the production systems are desired under the following main categories: production inventory, scheduling and the shop floor assignment, quality control. Now, let's talk about the production inventory and resource planning. There are actually two challenges in this area. The first one is the uncertainty in the demand, which all the firms face in their work. Second thing is the variability in the manufacturing system. So, regarding the uncertainty in the demand, simulation methods and so many applications are used and logarithms are used to expect or anticipate the demand in the future or the coming years. The second thing was the variability in the manufacturing system. So there are actually plenty of concepts in the manufacturing systems, such as just-in-time, JIT, manufacturing resource planning, MRP2, enterprise resource planning, ERP, we have lean, agile, agile manufacturing systems. These systems are applied in the manufacturing firms based on the business nature. For the scheduling and the shop floor assignments, we have the sequencing of the job and we have lot sizing. In the sequencing of the jobs, actually we have parallel machine scheduling, PMS, and we have flow shop scheduling, FSS. Now, on the other side, we have lot sizing. The economic lot sizing and scheduling problems based on the continuous time model and capitalized lot size based on the discrete time models. The main purpose in the lot sizing is to determine the lot size and the sequence of the lots while minimizing the setup and the inventory costs. Now, the third aspect is the taxonomy of manufacturing systems. In the taxonomy of manufacturing systems, we have from technology perspective and production philosophy perspective. From technology perspectives, the recent technology nowadays adopted and followed by many manufacturing firms are CNC, the computerized numerical control machining, the CAM, computer-aided manufacturing, and the CIM, which is the computer integrated manufacturing. From production philosophy perspective, the manufacturing systems are recognized under lean manufacturing, agile manufacturing, and agile. I'm going here to elaborate to some extent the difference and to distinguish between the lean manufacturing and agile manufacturing and the agile. Now, first, the lean manufacturing. For the lean manufacturing, actually it's concentrated on eliminating of the waste, non-value added activities, as much as possible, such as the transportation, the inventory, the motion, waiting the time. So the main focus of the lean manufacturing is to increase the efficiency, minimizing the waste, and at the same time they use just-in-time strategy. For the just-in-time strategy, where the products are delivered in small quantities and have the short lead times. So they adopt the pull system actually in the manufacturing, rather than the other strategies which they adopt the push system. Now, the second manufacturing system was the agile. On the other hand of the manufacturing systems, we have the agile manufacturing. In the agile manufacturing system, the capability to meet the rapidly changing demand of the market in both terms of the volume and the variety of the products. So, the focal point and the bottom line of the agile manufacturing is to be different, to differentiate from the market. So you are going to spend more money to be different and to produce variety and plenty of the products and to extend your product lines. So the agile manufacturing uses the make-to-order strategies. Now, the Lean Agile, actually it's a hybrid system, or you can say it's a hybrid strategy. So some firms will start in the lean manufacturing, and to some point they are going to shift to be agile. So this is, we call it like Lean Agile. But the point here is the upstream, which is the producer, from the decoupling point is a forecast driven at expected demand, in which it acts based on the lean concept. So the upstream will be the lean, the producer will adopt the lean manufacturing first. Then on the other hand, the downstream will be the consumer. The consumer actually will be the agile. So the decoupling point here is pulled by the customer, in which it acts to be agile concept to respond as quickly as possible to the volatile market. From the inventory and control perspective, we have also some of the strategies in the production that are adopted by the manufacturing firms, such as engineering to order up to make to stock. And here we can see the responsiveness rate. It will be very low in case of engineer to order, but on the other side, it will be high in the customization. In contrast, for the make to stock strategy, the responsiveness rate is very high, while the customization is very low. So you cannot customize your product in case of make to stock strategy, because it will be available in the inventory and you will just going and pick and grab your finished good or your product. While in the engineer to order, you are going to furnish various and plenty meetings and discussions between the customer and between the manufacturer, because you are going to customize and to custom build your equipment or your product. Now, from production control strategies, we said that we have a push system, we have pull system, and we have hybrid push and pull systems. In the pull system, the parts will be pulled from the supplier based on the actual demand. And it uses just-in-time strategy, as we have aforesaid, where no inventory exists. On the other side, the push system push the products to the retailers based on the forecasted demands. So the supplier here is going to push the materials, is going to push the products to the manufacturer based on the forecasted demand, and taking in the assumption that they will be sold. Here I'm going just to highlight some difference between economy of scale and economy of scope. Actually, the old strategy is economy of scale. The economy of scale refers to saving in the cost due to the increase in the output produced. So I'm going to produce high quantity, so I'm going to incur lower cost. Now, the relatively new strategy is economy of scope. So the shift here from the economy of scale to economy of scope is you are going to save the cost and you are going to lower your production cost due to the production two or more distinct products. So you are going to produce plenty of products, variety of products, so that you are going to save and lower your cost. Now, the cost advantage, as we said, for the economy of scale, it was because of the volume, because you are going to produce more quantities, so you are going to incur lower cost. But the cost advantage in the economy of scope is due to the variety, because you have plenty brands or plenty types of the products. Okay. Now for the remanufacturing. Actually, in the remanufacturing, we can you can say describe it like it's a process of restoring non-functioning discarded products to like new performance. So you are going to take the expired product or this non-functioned product and you are going to do some modification on it in order to become like a new. In the remanufacturing, actually, it will be environmental regulations is there, consumer interest in the green products, also potential profitability of salvaging the operations have motivated manufacturers to consider the remanufacturing as part of their business models. So now many of manufacturers actually they consider the remanufacturing in their business models because due to the environmental regulations, due to the reducing the waste, and because of the consumer interest in the green products. If sometimes the customer or the consumer will ask for the green products. Okay. For the new manufacturing discipline, we have the smart manufacturing and smart supply chain. Actually, there are plenty of articles talk about the smart supply chain and smart manufacturing. Here is just like a summary about this, that the advanced manufacturing systems equipped with the hundreds of sensors facilitate the collection of the huge amount of the data known as big data and they provide opportunities for enhancing the performance of manufacturing processes. However, big data technologies are shifting from data collection to data analysis and outcome. For the advanced manufacturing, we have nanomanufacturing. And the nanomanufacturing is defined as the production of the materials and the structures with at least one literal dimension between 1 and 100 nanometer. The nanomanufacturing technologies are categorized as top-down and bottom-up and hybrid technologies. For the semiconductor manufacturing, the technologies used for production of the semiconductor devices such as integrated circuits, microchips, nanowires, microsensors, inject nozzles, and laser diodes are identified as microfabrication technologies. As a conclusion and the future trends, we have the direction in the context of manufacturing and summarized here in the 5 criteria: the objective, the business model, emerging technology, advanced scheduling, and enabling factors. The bottom line question now is, are all of these aforesaid concepts adopted in the manufacturing firms? In fact, the answer is no. Each manufacturing firm follows the practices and the principles which comply with its business nature. I'm going to tackle now a real example of an HVAC manufacturing firm. For instance, to elaborate some of the perspectives that are prevail in its production system. Going back to the manufacturing process. For the manufacturing process aspect, we can realize that multiple processes are applied to the sheet metals such as cutting, bending, welding, and finally painting. So each HVAC finished product has its own distinguished design. Accordingly, the designers shall release the final drawings to the shop floor in order to fabricate the sheet metals which is complying with the design drawings. From industrial control system aspect, In case of multiple units are required for a project, the units will be supplied with a dedicated supervisory control panel in order to allow the customer connects his SCADA or DCS system with one single communication provision with the HVAC units. For the material handling system, you can plainly see the forklifts and the cranes are utilized to shift the materials as well as the finished goods products at the shop floor. For the production aspect, due to the high uncertainty in the HVAC demand, the HVAC firms vary in the production systems that is adopted by each firm. Some firms follow just-in-time concept where no work in process inventory exists and lean manufacturing principles are applied, in which eliminates the waste and the non-value added activities. On the other hand, some firms concentrate more on the variety in the products and to differentiate from the market to meet the rapidly changing in the demand, where agile manufacturing principles are applied. Nevertheless, all HVAC manufacturing firms adopt a reasonable procedure in releasing the required parts with their quantities to the MPP department. MPP department is the Material and Production Planning Department. This department is responsible to schedule the materials, schedule the finished good, and to release the orders to the suppliers and the vendors. A comprehensive bill of material, BOM, relevant to each unit shall be furnished by engineering department and released to the MPP department in order to procure the required parts and the sub-equipment. For the inventory control aspect, the standard units with no customization, such as consumer products like window AC or split AC, will be manufacturing as make to stock. On the other hand, the highly customized units where the customer involvement is required, so it shall be manufacturing as engineer to order. At any rate, many manufacturing firms will have also in the production systems, they will have the single flow and they will have the parallel flow in sequencing the manufacturing units. At the end, I would like to thank you for your listening, and this was a real example of the manufacturing systems for HVAC manufacturing firms. Moreover, I would like to stress that this article is very useful for the engineers who are working in the manufacturing firms, and for more information you can review the article presented just before a while here in front of you, and you can dig more in each subject if you want to get more information and to acquire more knowledge about that topic. Thank you again for your listening, and see you later in the future lectures.